Hi again, welcome to the next video in the calculus series. In this video we introduce the integration technique referred to as the reverse chain rule. It is a big help when we have two functions which are combined and we have to integrate the whole thing. As we noted in the basic integration video, some of the formats of terms or functions to be integrated had terms inside brackets which were raised to powers or which had simple denominators. These terms sometimes had to be simplified by expanding or by dividing. Single terms gave us no problems. Sometimes, however, we encounter terms which are a bit more complex. The complexity is often due to there being two terms, either multiplied together, or one function is divided by another, or sometimes one term is pushed up as an index. But in all of the examples we deal with having these formats, one of the terms in the function to be integrated is the derivative of the other. For example, we might have the integral of bracket 2x plus 1 bracket x squared plus x minus 42 all cubed dx. Note the derivative of the second term in brackets, x squared plus x minus 42, just ignore the index for now, is the same as the other term in brackets, 2x plus 1, ignoring the multiplicative constant if we have any at all. The derivative relationship is the key aspect of this integration technique. Naturally, I will not and cannot in all conscience talk about a formula which you would use like a robot. We will, every time, work through the maths to ensure we apply the right strategy, and therefore we will have to suffer the consequences of obtaining the correct answer every time. Let's do an example. We're going to integrate bracket 2x plus 1 bracket x squared plus x minus 42 all cubed with respect to x, so we write dx. Step 1, and all of these steps are on the website, identify the function with the highest power. Now we've got two of these two functions. Clearly x squared plus x minus 42 has a higher power or higher degree than 2x plus 1, so we put u is equal to that. Now we differentiate. Instead of writing du dx, we're going to separate it so that the u's are on one side and the x's on the other. So we're going to write du is equal to the derivative, which is 2x plus 1, times the dx. Sometimes in step 3 we have to adjust the coefficients on the equation that we have just created, but we don't in this case, so I'm just going to move straight on into step 4. Now this is an important one. In steps 1 and 2, we've established two different relationships. Now we look for those relationships in our original equation that we had to integrate. And we can see that the bit in the big brackets, x squared plus x minus 42 all cubed, is really u, and so we can replace that with u cubed. And in the other part we have 2x plus 1 dx, and we know that that now is du. So we substitute for both of those components and we have our integral as equal to u cubed times du. We now do the integration that we've established in step 4. So integral of u cubed is simply u to the 4th over 4. And then, most importantly, we substitute back again for our term in u, which is x squared plus x minus 42. So our result is x squared plus x minus 42 all to the 4th over 4 plus c, don't forget the c. Okay, let's do a second example. We're going to integrate 12x squared minus 8x all over x cubed minus x squared plus 5 all to the 10th times dx, because it's with respect to x. Now we look at the structure of the fraction, and we don't like fractions in integration very often, except if they're very, very simple. And this is a complex one, so we think probably a reverse chain rule is required. So now we try to establish our derivative relationship, and we can see that x cubed minus x squared plus 5 differentiates to 3x squared minus 2x, which is a factor different from the numerator. So yes, we do have it. So we're going to let u is equal to the bit in brackets in the denominator, which is x cubed minus x squared plus 5. Then we differentiate. Du is equal to 3x squared minus 2x dx. To get to our numerator of 12x squared, we need to multiply the result of step 2 by 4. So we do that. 4 du is equal to 12x squared minus 8x dx. Now, we need to use those two bits of information in respect to our original integral. So we can see that 12x squared minus 8x dx is equal to 4 du. So we can write 4 integral sign and then the du at the back. And the denominator is really u to the 10th, so we can write that as u to the minus 10 to save time. Then we can integrate that, so it's 4 u to the minus 9 over minus 9. And then we substitute back from the u to the x terms, and the integral is equal to minus 4 over 9, x cubed minus x squared minus 5, all to the 9th, plus the constant c. A final and very common example is the integral of x plus 2 over x squared plus 4x plus 8 times dx. Now we have a fraction, not very nice, so therefore we think it probably is a reverse chain rule, and we can see the derivative of the denominator is going to be 2x plus 4, which is a factor of 2 different to the numerator, so yes, confirmed. So let u is equal to x squared plus 4x plus 8, du is equal to 2x plus 4 dx. Now to get back to the x plus 2, we're going to divide both sides by a half, and then we can do our substitution on the basis of the information from steps 2 and 3. So the integral is equal to a half and then the du after the integral sign, and our x squared plus 4x plus 8 is in the denominator, so we'll put the du over u. Now clearly du over u or dx over x is simply a log, and so our integral is a half log u to the base e, and then we replace the u, and so it becomes a half log x squared plus 4x plus 8 plus c. In conclusion, just a couple of quick comments. Sometimes the substitution of u equals something or other is given to you. Of course, that makes the solution a lot easier. You don't have to look for the substitution yourself. Secondly, if you have to evaluate a definite integral with the reverse chain rule, do all 6 steps before substituting. With very advanced applications, you may do something different, but it is a much more straightforward step to obtain your integral in terms of x first, and then substitute as you usually do. So there it is, the reverse chain rule, covering basic questions perhaps up to extension level. Note they're all done in exactly the same way. There is a summary of the steps to follow on the website. Please don't use a formula, use your understanding of mathematics, because that's what we're really here for. Thanks for watching this video. Hit the like button and subscribe if you haven't already. Also go and do some reverse chain rule questions in Test Yourself 1 on my website at drjaysmaths.com. Add a comment below if you have any questions. Good luck. See you in another calculus video.